Welcome to Study Loop.
In this problem, we have a collar here sliding on a track. It is straight in these regions, and then it's a circular arc in these regions. I've drawn it fairly poorly. It's in 3 dimensions, and then there's a spring connected to the collar that's attached to a point above the track. So we know, we're given that the unstretched length of the spring is 300 millimeters. The spring constant is 150 newtons per meter, and the collar weighs 0.75 kilograms. We've defined a few points on here. This is F here. So that is, and I'm using this as my origin here. So F is 350 millimeters above the origin. A, where the collar is initially, is 400 millimeters to the right of the origin and 500 or 400 millimeters down from the origin, I guess if you want to call it, and 500 millimeters to the right. So we just use conservation of energy here. Our initial kinetic potential energy is the energy in the spring. We have no zero kinetic energy because this thing is released from rest. At point B, which is a point here just before it hits the curved part, or just as it hits the curved part, we're asked to determine the speed at that point, and then also at point E, which is directly over from where the collar started. So at point B, we have again some spring force, some spring energy, and we also have some kinetic energy. And at E, we have the same. Now we can figure out these the length from A to F, just taking the position vector A minus F and taking the length of that, and we get basically this expression, just all of these terms squared and the square root of that. From B to F, again, taking the position vector to B, which I guess I didn't write here, but the position vector of B is simply, let's see here, in the 0, 0, 200. So we can find the length B to F and also the length E to F, and that the length E to F is, let's see here, 500, 500, 0, minus 350. So again, we have all the values here, and then we also have some kinetic energy there. So again, we know that our kinetic energy at B must be the difference in potential energy from A to B, and the kinetic energy at E must be the difference in the potential energy from A to E. And those give us 2 equations to solve for the velocity of at B and at E. And at B, it's 5.12 meters per second, and at E, it's 4.20 meters per second.